Now, in this video, we will going to take up one more program to write a Python program to check the entered number is prime or not. So, what is a prime number? A prime number is a natural number greater than 1 that has no positive divisors other than 1 and itself. What does that means? Suppose if I consider 1 is not a prime number, so it is greater than 1. Can I take it 2? No. 2 is also not a prime number. When I want to take up 3, 3 is a prime number. It is divisible by 3 and it's one number. And it's 1. Suppose can I take 4? No. Can I take 5? Yes. 5 is divisible by 1 and by itself. So that is the reason why it is called as a prime number. For example, 5, 11, 19, etc. are the 5 numbers. So how to write the code for this? For num integer input, enter any positive number to check whether it is prime or not. So here I am trying to give the input through the keyboard. The moment when I give the input through the keyboard, always in Python, it is considered as a string. So I want to convert that string into an integer. So that is the reason why I am using integer function. Int input, enter any positive number to check whether it is prime or not. So the condition is, then I want to check, since I want to check, so he says number should be greater than 1. So I will apply an if condition. If number is greater than 1, the condition is true. Then what it should do? Suppose if I consider 5. So what is that range? So when it is a prime number, if it is divisible by itself and 1. So that means the remainder should not be equal to 0. If the remainder is 0, then it is not a prime number. So if I want to check, suppose for example, I want to check the number 5. If I want to check the number 5, is 5 is divisible by 2, is 5 is divisible by 3, is 5 is divisible by 4, and every time I need to iterate that, so that in all these cases it should not be divisible by that number in any other number other than 1 and itself. So that means the remainder should not be equal to 0. If the remainder is equal to 0, then it becomes not a prime number. So since I want to iterate number of times, so I have to use a for loop. For I in range 2, num. Then if this condition is true, then I want to check what is that. Is that number is having a remainder. If number percent I is equal to 0, that is the remainder is equal to 0. If this condition is true, print num is not a prime number. So if I say, suppose if I take 6, what is that number? If 6 is greater than 1, condition is true. For I in range 2, 6, correct? 6% I is equal to 0. So that means I have to start dividing by 2. So 6% 2 is the remainder is equal to 0? Yes. So 6 is not a prime number. That is when it is divisible. Now again I want to check. 6 divided by 3, again the remainder is 0, though num is not a prime number. Again if you go back, 6 divided by 5 is not equal to 0, correct? Remainder is not equal to 0, but then 6 has to become prime number, but it is not. So that means the moment when you get in any one of these iteration is equal to 0, then that number is not a prime number. Simple. So if 6 is divided by, even though you have num is equal to 6, so 2, 3, 4, 5, I need to check. But in 2, 3, 4, 5, if any one of these numbers is divisible by divisible, then that number will not be considered as a prime number. So I need to apply a break. So that is the reason why I have applied a break condition here. Once I get into the actual code, I will going to show you how this is going to work. Else, if this condition is not true, else That is, once it is broken. So that means I am breaking the loop. Else, num is a prime number. Okay? 5 is a prime number. Else, that means if num is greater than 1, if this condition is true, then only it will go to this. Then, otherwise, num is not a prime number. Is not a prime number. So, is 1 is a prime number? No. So, 1 is not a prime number. It automatically comes to this. So, this is how you will be able to write the program. But how exactly it will go to check output? Enter any positive number to check whether it is prime or not. 1 is not a prime number. Sure. Then, enter any positive number to check whether it is prime or not. 19. 19 is a prime number because 19 is divisible by itself and 1. Then 20 not there. 20 is not a prime number because 20 divided by 2, that remainder becomes 0 there. So that is why it will not be a prime number. So 20 is divisible by what? It is divisible by 2, it is divisible by 4, then it is divisible by 5. But every time you need not have to check. Once you apply a break statement, then the moment when in the first number when it becomes is equal to 0, then you need not have to check again. So that is the reason why we are applying the break statement. Now we will go to this. So enter any positive number to check whether it is prime or not. 1, if num is equal to 1, is 1 is greater than 1? No, condition is false. So 1 is not a prime number. Sure. Then enter any positive number to check whether it is prime or not. I am entering 5. Num is equal to 5. I am assigning the variable value. I am assigning the variable num with a 5 value. Is 5 is greater than 1. Condition is true. Then enters into the for loop. So for I in range 2, num. What is num? Num is 5. So how many cases you need to check? 2, 3, 4. Is I is equal to 2? First one. I is equal to 2? Yes. 2 is within 5. Condition is true. If num percent I is equal to 0, what is num? 5. I is 2. Iteration. Is this remainder is true? Remainder is equal to 0? No. False. Then it increments I is equal to 3. 2 plus 1 it becomes 3. 3 is within 5. Condition is true. 5% I is equal to 0? No. Condition is false. Again it goes back. Then it checks. Then it increments. I is equal to 4. Condition is true. 4 within 5. 5% 4 is equal to 0? No, condition is false. Again it increments. 5. 5 within 5? No. So condition becomes false. So therefore it comes out of the loop. Then it checks. So it is not a prime number. Sorry. Since it is not a prime number, since 5 is not divisible by 2, 3, 4, therefore 5 is a prime number. So this is how you will be able to execute this program. Now we will going to try to check how it will going to be written. So first I will come to this. So here I will write num int input, num equals int input, enter any positive number to check whether it is prime or not. It is prime or not. Okay. Next, if num is greater than 1, condition is true for I in range 2, num. If this condition is true, if num percent I equals 0, correct? Print num is not a prime number. Print num is not a prime number. Is not a prime number. Okay. Then I will go to break this statement. Break. Else num print num is prime number. Num is a prime number. Is a prime number. Okay. then else. So here print num is not a prime number. Okay, this is how it will be executing, is not a prime number. Now we will try to check how it will going to be written. Suppose I will take the first number. I will take 1. 1 is not a prime number. Yes. So how I will go to check 1 is not a prime number? I will go to this. I will place it within the breakpoint. Sorry. So I will go to this debug-python file. First I am going to enter positive number. I will take 1. So 1 is greater than 1. Condition is not true. So it comes to 1 is not a prime number. Okay. Now again I will go to this debug-python file. Then check. Then I will take 2. Is 2 is greater than 1? Condition is true. 2 comma 2? No. 2 is a prime number. Yes. Then I will go to check 3. Okay. Take the num value as 3. 3 is greater than 1. Condition is true. For I in range 2 comma num. Yes. Num percentage 3% 2 is equal to 0. No. Again it will try to check 3. I is equal to 3. No, it won't, because 3 is the range itself is 2 comma 3. So it will check only once. So again 3 is a prime number. Now I will go to check with 5. Now I will come to this 5. Okay. Enter. Is 5 is greater than 1? Condition is true. 2 comma 5 means 2, 3, 4. It needs to check. You check here. You see. First it will check for I is equal to 2. 5% 2 is equal to 0. No. Then it goes to 3 now. Then 5% 3 is equal to 0. No. Then I becomes 4 now. 5% 4 is equal to 0. No. Again it goes. But 5 itself is the last one. So it comes to this. So 5 is a prime number. Okay. Now I want to check it for 19. Let us see how it will go to take. So then go to this num. I will check 19. See how the difference is. How it will go to work. You should understand this. 19. And then press enter. Then 19 is greater than 1. Yes. 2 comma 19. So 19 comma 2. So remainder is not 0. 3. Remainder is not 0. 4. Remainder is not 0. 5. Remainder is not 0. 6. Remainder is not 0. 7. Here you just check here what I am doing now. 7. 19. 7 is equal to 0. No. Again it goes back. Then 19. Then 10. 19. Now it is 9. Okay. Next 19. Then I is equal to 10. 19 10. No. 19 11. 12. 13. 14. 15. Okay. Here is 15. Then it is 19. So for every number, for every iteration it will check the number. So now previously, now it is 16. Okay. Now it will go back. Again it takes 17. Yes. Then again it will check for 18. So till it becomes 18. It's not there. Now, so in none of these cases from 2 to 18, it is not divisible by 0. Therefore, 19 is a prime number. This is how it will go to execute. Suppose if I want to check it for 20. Let us see how it will go to functions. So you take num, I will take 20. So 20 is greater than 1, condition is true. I, 2 comma 20. 20 divided by I, 2. So here it is 20. Here is I is equal to 2. When I divide 20 divided by 2, what is the remainder? Remainder is 0. So it will comes to this. So 20 is not a prime number. Prince. But it will not go back, because once the number is divisible by other than 1 and itself, so naturally that is not a prime number. So obviously you will going to break that. So it comes up. This is the advantage of using the break statement. So this is how I will be able to check whether the given number is prime or not in Python program. Thank you.